Hello and welcome to the 6.4 nth roots notes videos. Here at the very beginning I'm going to go over what a radical is, what an nth root is, and go over example 1. That way you can excitedly get started on your homework because I know you're just dying to do it. So 6.4, you're going to be simplifying radicals, and then you're also going to use a calculator to approximate radicals. So you better have a scientific calculator. If you do not have one, I guess you're going to have to pony up some Christmas dough to go buy one. Or ask your parents for an early Groundhog's Day present. So, here we're going to be simplifying radicals. We're going to find the square root of a number and squaring a number. These are, as you guys know, these are called inverse functions. So, we want to write inverse in here. Inverse functions. Inverse operations. We already did inverse functions. So, whenever you square something, the way of getting rid of it is to square root it. And vice versa. Kind of like multiplying and dividing undo each other, adding, subtracting undo each other. So, the inverse of raising a number to the nth power is finding the nth root of a number. So for example, if you have the x to the third equals 64, then getting rid of this third root, getting rid of this power of 3 means you're going to take the third root of it. So taking the third root of 64 would give you a 4, which means that on the side over here, if you take 4 to the third power, that is going to be equal to a 64. Same thing if you have a power of the 4. Oh, hi, there's a little 3-year-old just, kidney punched me with his Hulk hands. That's not cool. Hang on, breather. Okay, sorry. Okay, alright, I'm back. Alright, so same thing if you have an x to the 4th, and you want to find out, to get rid of an fourth root, then this should say 4 right here. Small typo. Fourth root of 625 is 5. So that means that if you take 5 to the 4th, you should get a 625. Okay, so we've gone over the definition of an nth root. Some numbers have more than one real nth root. So if you take an example, 49 has 2 square roots. So if you take the square root of 49, you actually get a plus or a minus 7. Because you can take 7 times 7 to get a 49, or you can take negative 7 times negative 7. Well, the positive answer, we actually have a special name for this. This is called the principal root. Principal root. Now, anytime we have some rules here. Anytime that a is, don't you guys just love hearing a 3-year-old in the background? If your a value is greater than 0 and n is even, so that means your nth root is even, then you have a one unique positive and one unique negative real root. Your positive root would be your principal root. If n is odd and a is greater than 0, then you have one unique positive and 0 negative real roots. These are just rules here, so if they don't make sense, you will find out when they don't make sense. Now, if a is greater than 0, or less than 0, here we have, if a is less than 0 and n is even, then you have 0 real roots. That means if you have like a square root of negative 6, okay, we know that doesn't have a real root. It has an imaginary root. So a would be less than 0, and your n is an even number. Now, if n is odd, so say it's a third root of negative 6, then this actually has a real answer. What you'd be able to do is you'd be able to take out, since you have an odd number, you'd be able to split this up into a third root of negative 1 and a third root of 6, and the third root of negative 1 would just become negative 1 times the third root of 6. Third root of 6 is a decimal, but it can't be simplified any further. And then finally, if a is equal to 0, that means you'd just be taking the square root of 0. So if you're going to be taking the square root of 0, you're just going to get a 0. If you take the third root of 0, you get a 0. So anytime you get a 0 underneath your radical, no matter what your index is, you always get 0. Okay, so let's get into simplifying some roots. So if you have a plus or minus in front of your square root, or your cube root, whatever kind of root it is, it doesn't matter, then you're going to end up getting a plus or minus in your answer. And when you simplify these, what I like to do is I like to split them up into two different things, because you're going to be simplifying the 16 separate from the p to the 8th. So if we find a square root of 16, you are going to have a square root of 16 times a square root of p to the 8th. So what you're going to do is to find your square root of 16, that just is a 4. And then to take the square root of p to the 8th, you get a p to the 4th. Well, how in the world do we get that 4? Well, what you're going to do is you're going to take this 8 that's underneath your radical, and you divide it by your index. In this case, it is a 2. We just don't write the 2. So when you take 8 divided by 2, you get a 4. And that is your root, or your power of your p. Now for b, we have a negative out front. So since we have a negative out front, what we're going to do is we're going to have a negative in our answer. But we're going to have to take the 4 and we're going to divide it by the 2 that's written out front. Whatever's inside your parentheses, you cannot touch. You just leave it. Leave it alone. Leave it alone. So, you are going to get a q to the 3rd power plus 5. You don't mess with it. You just leave it in parentheses. And then you're going to take this 2, or this 4, and divide it by 2, which will give you a square. So that's your answer for B. Now we're getting into the big boys. Here for C, you are going to have to do a little simplifying here. You will divide, not divide, but I like to separate my numbers from my variables. So I'm going to be simplifying 3 different things here for letter C. You're going to have a 5th root of 243. That's nice, 243. Let me rewrite that maybe. So you're going to have a 243. You're going to have a 5th root of a to the 10th. And you're going to have a 5th root of b to the 15th. So when you simplify each of these, you are going to need to know your perfect 5th roots. Well, we know this is not a 1 to the 5th power. It gives you a 243. 2 to the 5th power is going to give you an even number because you're multiplying an even number 5 times. So that's not a 2 to the 5th. The next number would be a 3 to the 5th, which in this case actually works. So you're going to get a 3 times, well, here you have to take a to the 10th divided by the 5. So 10 divided by 5 is going to give you an a to the 2nd power. And then b to the 15th, you're going to have to divide this 15 by the 5, and that's going to give you a b to the 3rd. So see, by simplifying each individually, numbers and different variables, you can make your case a little bit, or I think it's easier to just see your work here. Now for letter D, what you have to do here for letter D is, first off, this negative is going to come out as an I. So you have really an I times square root of 4y to the 12th. So if you take the square root of 4, that's going to give you a 2. If you take a 2, or a 12, I'm sorry, if you take this 12, and you're going to divide that by your 2 out here, that's going to give you a y to the 6th power. So we can't forget what we took out at the very beginning, our I. You put that at the very end. By putting it at the end after the y to 6, you're going to find out that you're going to have an imaginary answer. So that is how you find roots of simple radicals.